Question number 58, CY 2022. Calculate the magnetic moment of cerium 3+ complex in Bm. This is a numerical type of question, so no option is given. So coming to the answer, before starting any calculations, we have to know few things. So first, orbital magnetic moment of transition metal ions and lanthanides. In case of transition metal ion, it is mu equals to root over n into n plus 2 Bm, where n equals to number of unpaired electrons, and mu for lanthanide is mu equals to Gj into root over j into j plus 1 Bm, where Gj equals to Landé factor and j equals to total angular momentum. The reason behind this difference in calculation of magnetic moment between transition metal ions and lanthanide ions is the spin orbit coupling. Which is usually called Russell-Saunders coupling. To know more about this coupling, we have to look into the valence orbital configuration of transition metal ions and lanthanide ions. For transition metal ions, like iron 2+, nickel 2+, cobalt 2+, valence electron is in the d orbital, but for lanthanides like cerium, lanthanum, the valence electrons are in the f orbital. Now coming to the electronic configuration of cerium, which is 4f1, 5d1, 6s2. Thus cerium 3+ is 4f1. If you draw it, 2, 3, 4, 5, 6 electron, it is here. So this is f orbital. These are ml values. Since the valence electron in case of cerium or any lanthanides is present in the f orbital, the f orbital is situated very deep than the d orbital or s orbital or p orbital. Thus, the effect of ligand is very much less or negligible on the f electron. But in otherwise, if you go through the periodic scandium, yttrium, lanthanum. If you go down to scandium, yttrium, due to the opening of new valence shell, the size increases. But if you go from yttrium to lanthanum, in spite of opening of new valence shell, the size remains same. The reason behind this lanthanide contraction, and thus the f orbital having two different scenarios. In one case, since the f orbital is situated very deep, the effect of ligand field is very much less or negligible, but due to the lanthanide contraction, effective nuclear charge increases. Thus, the spin magnetic moment and orbital moment contributed to form the total magnetic moment on the lanthanide ion. But this is not the scenario in case of transient metal ions, since the d orbital is very much affected by the ligand. Thus, there is a difference in the magnetic moment calculation between transient metal ions and lanthanide ions. Now, coming to the formula of lanthanides. Gj equals to 3 by 2 plus S into S plus 1 minus L into L plus 1 by 2 into T plus 1. J equals to L minus S for n less than equals to 7 and L plus S for n greater than 7. For half fill or less than half fill, J equals to L minus S, and more than half fill, J equals to L plus S, while S equals to maximum spin multiplicity, that is summation of small s, and this is spin moment, summation of spin moment. This is half, since one electron is there in cerium 3 plus ion, and L is maximum orbital angular momentum, it is summation of ml, since this is 3. Now coming to the calculation part. J equals to L minus n, since only one electron is there in case of cerium, 3 minus half equals to 5 by 2. So in Gj formula again I am writing now, putting all the values of S, L and J. To find this. Now by simplifying this, this can be rewrite as it can be transformed into this can be rearranged as like this. So the value of Gj is 6 by 7. Now coming to the calculation of mu, which is mu equals to Gj into root over J into J plus 1 Bm for cerium 3 plus or any lanthanides. So value of Gj I am putting here, then the value of J. This can be rewrite as like this. This is 3 into root over 5 by 7, which is 2.53. So the magnetic moment of cerium 3 plus complex is 2.53 pm. The reference you will find in the NPTEL lecture on Russell-Saunders coupling by Professor Devbrata Maiti, Department of Chemistry, IIT Bombay. Thank you very much.